Okay, welcome to a quick lesson on multiplying two-digit numbers using base 10 blocks. So this is a great app called Braining Camp. It's free for 30 days. Not sure if it's just teachers or parents or everybody, but at any rate, this is what we're going to try to use. It's new for me, so it's a bit of a struggle to try something new, so bear with us. But if you're going to do the standard algorithm of 24 times 15, let's talk about what that means. So what it means is I need 24 groups of 15. So right now at this moment, I have, in this direction, I have 1, 2, 3. If I go all the way down, you'll know that's 10. So far I have 10 groups. This is 10 plus 5. So I'm going to need to bring in 5 more guys. There's another group of 5. So now I have 15 in all of those guys. If I count them all, there's 15 of them. Now I need to have 24 of those set up. So I have it's basically like I have a rod and then 5 ones. That's what that looks like. So in this direction, I'm going to end up with 24 groups of that. So there is a group of 10, another group of 10 makes 20, and 4 more groups makes 4. Now remember this, whoops, sorry about that. I need to erase him. This is a rod with 5 ones. There's 4, and there's 5. So I did that, but I built it using hundreds because I know that if I had 10 rods next to each other, because I'm going to have 24 of those groups, I'm going to have at least 10 and another set of 10. I'm going to be able to use the hundreds blocks. So let me take these off. I just wanted you to see that that was a group of 15. And I don't want the whole thing. I just want that little guy. There we go. So I can erase all of this stuff just to reduce the noise of space up here. Now let me highlight this crew, and then I will bring him because I need another set of 15. So currently I have, remember, a rod, I have a 10 and 5 ones. I made 2, 3, 4, 5, 6, 7, 8, 9, 10 groups of 15 going down. I have another set of 10 going down, so that makes 20. I almost have them here. So these guys, I am going to be putting them all over here. There is my set of 15 going down. That's my 21st set of 15 going down. So I need to build a few more sets of 15 going down. Okay, so I can use, when I know my numbers, when my two digits, my two factors in this problem are going to be higher than 10. This, I can go ahead and say there's actually 20. That's higher than 10. 20 plus 4. And I can say that I can definitely use these guys and make a group 24 going this way and a whole group of 15 going that way. So it's really kind of cool to see it laid out like that because multiplication is always done, we call it like area model. Okay, it's always a rectangle. Whatever you have here, so 15, and you have 24 here. Multiply both of them and it will always always come out to be either a perfect square or a rectangle. So I'm going to show you a different thing with that in a minute, but that's what we're doing is the area model. So let's count what we have here. If I said 5, I take my ones, 5 times 4, okay, 5 times 4. If I take that and I have 5 ones times 4 ones, there's 1, 2, 3, 4. I have 4 going across. This is 4 groups of 5. So I have 1, 2, 3, 4, 5, and I've got 4 times 5, and the answer is 20. So if I count all these yellow guys, there are 20 of them. Then I say, so I would look, it would look like this. I'd put the 20 like that. This is 5 groups of 20. 5 groups of 20. Well, there's 10, 20. I have 1, 2, 3, 4, 5 groups of 20. And my answer for that is 100. 10, 20, 30, 40, 50, 60, 70, 80, 90. I have 100 blue guys right here. Now, what we do in math is when we do the algorithm, it's 5 times 2 is 10, so that makes it 5 times, basically it's 20. It's I'm multiplying 5 times 20 here. But we say 5 times 2 is 10, and then we add that. So what we're doing is regrouping, because I can't really have big groups of, I can take this and I can bundle. I'm bundling it in groups of 10. So I'm actually going to take these bundles, make nothing here, and I'm going to make this 120, because I can bundle these guys into rods. So this is actually looking like that. So this entire row on the bottom is 120. Now I'm going to say I don't need him anymore. 1, which is actually a 10, so I put it, that's what that placeholder is about. It's not really a placeholder, it's really helping you understand you're multiplying by a 10 now. 10 groups of 4. So here's 1, 2, 3, 4. And I have 10 groups of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 groups of 4. And that is worth 40. So 1 times 4 is 4, and look what it ends up being, 40, just like I had right there. This is 1 group of 2. It's really 10 groups of 20, isn't it? Because this is worth 10, and that's worth 20. So I need 10 groups of 20. Here is 10, 20. And I have done this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. I have 10 groups of 20. And that equals 200. You can see I clearly have 200s there. So this is 200. So what do I have on the top row? 240. This whole section is worth 240, and it looks like it right there. This bottom section, all of that is 120, and it looks like that. If I add them all up, 40, so 20 and 40 is 60. Now, that is a 6, and that 2 plus 1 is 300. And this is why you have to add and multiply when you're doing an algorithm method, because you're bundling this crew and you're adding this crew and this crew together, so you're constantly bundling things together. And our answer is 360. The machine counts these for me. So all of these are matching. I have one more way to show you this, and I'm going to put it over here. I can do this box. I have a 2-digit number on the top, and I have a 2-digit number on the bottom. So I'm going to need 4 boxes. You see how I already did expanded form right here? 24 is 20 plus 4. And the bottom number is 15, which expanded form is 10 plus 5. Okay, so now I multiply whatever is here. So I can say 10 times 20. I go 2 times 1 is 2, and I put in the number of zeros that are here. So I need 2 zeros. 4 times 10 could count as 10, 20, 30, 40, or I could say 4 times 1 is 4, and there's only 1 0 trailing at the end of that, so that's in that place. 5 times 2 is 10, so I write the full 10, and I still have 1 0 hanging up out right there. And 4 times 5 is 20. When I do this method, I always know that everything on the diagonal is going to be a place value. So this is actually, I have 200 plus 140 plus 20. Now you could do this a variety of ways. I can just add this whole thing up and get 360. Could also just add these two. 200 plus 40 is 240. And 100 plus 20 is 120. And I'm still going to get 360. I could bump. I could have done it this way where I did the 200 and I meshed the 140 together, and I know that that's going to bump that to 300. I know that this 2 is going to bump this to a 6. So I have 360 that way as well. So a variety of ways you can look at it, but it's really cool to see it laid out this way. I'm going to erase so you can see it all again without all this noise. And we're going to touch and count them as we go. It's really important that you understand that with place value, our whole math system is built on place value. So you really need to understand place value well. And by doing that, you bundle that when you have more than 9, it bumps it to a rod. See that I have 100, 200. Now let's see if I can make another 100. Well, there's 5. 1, 2, 3, 4. 5 sticks is 50. 50 and 50 is another 100. So I have 100, 200, 300. 10, 20, 30, 40. So right now I have 340. 344, 348. I know that 2 more. 49, 50. And then I know that I've got another set of 8 here and the 2 more left over, so it's 360. 1, 2, 300, 340, 350, 360. Okay, so it's 360, a variety of ways to count them. All right, see you later.